So essentially this category kind of breaks down different moments in client startup time, where this particular category then summarizes all of that into subcategories of clients, needing less than a second for MarvelClient to do its work, less than 4 seconds, less than 8, and then greater than 8. I'd like to take a look at the greater than 8 second. And scrolling over to the right, so what you see here is the number of milliseconds for each of those run types. In it, essentially, is a very short moment, after clicking on the node shortcut, which can take longer if you use roaming, for example, meaning MarvelClient roaming, because we would then, for example, roam data from a network drive to the local machine. If there is no roaming job, then that typically, shouldn't take longer than just a few milliseconds. However, we do occasionally have candidates that, when starting nodes along with a Windows boot storm, where the init can take several seconds. So that would be a first indicator that the machine is totally busy to even, do basic initialization of the Nodes client framework to even load our DLL. Init to before login pre is essentially IBM time. The bold columns are MarvelClient time, and the non-bold ones are IBM time. Before login pre is then a special runtime moment where you can schedule actions to do that, are supposed to be executed before login kind of pre, which again is a kind of a special moment. And if you don't have anything associated to it, then it should take anything close to 0 milliseconds. Then we have a jump where we're waiting for IBM to signal that we're close to the user being prompted the login screen, which could again indicate that we're waiting for the operating system or for the node client to do stuff. And in your case, that's not really an issue. Before login is then the moment where we're saying, okay, this is where we're close to having the login dialog display, and then we do whatever we're supposed to do before login, if anything. Then we have password entry or single sign-on. So if you have single sign-on, any lengthy period for the password gray column could also indicate kind of a performance issue. After login is typically the longest moment where we do most of our work, prepare data for the Analyze database, manage desktop icons, local replicas, and stuff like that. And then we have two summaries. One is for nodes and one is for MarvelClient. Now 10 seconds isn't really spectacular, but still it's 10 seconds. So we could have a look at why it actually takes 10 seconds for MarvelClient to do stuff on this particular machine, also assuming that you're currently not doing all too much anyway. So what we could do here is open the document, please. The file list on the first tab should be extended with, by the file name log.xml. Now that's not going to be all too spectacular by means of, I'm assuming you're not experiencing any performance issues, but nevertheless, click on the updated next to log.xml, please. Now in a MarvelClient log file, you'll see quite comprehensive logging as to what we're doing, etc. And without going into all details, every line has a number at the very beginning, which is the number of milliseconds that have elapsed since close to clicking on the node shortcut. Close meaning that the client has to first initialize a very, very basic set to then load our DLL, and then from that moment on we're starting our logging. And then we're ending logging once we're done with all the MarvelClient work, and the last run type being after log and after write. Now, if you have a client where you consider performance to be way off from standard or just in general close to what you consider to be long run times, then just press the page down key and see and look for larger jumps in that particular number. So there, what you can see is that we've currently just had a jump from something like 300 milliseconds up to 6.3 seconds, which is essentially 6 seconds. That's the only valid jump in a log file, because that's the time it took you to enter your password. Now, if you had single sign-on, then that should be close to 0. But in your case, kind of password entry, which should also be reflected in the respective runtime analysis view, showing 6 seconds for password entry. Got one jump from 6.4 to 6.6, which is 200 milliseconds, which is blazing fast, which is opening the config database. In most customer environments, that takes something around a second. But if you have a client, piling up multiple seconds, you could, for example, already see that you have a performance problem of Nodes clients talking to your dominant servers. In your case, that's about as blazing fast as I've ever seen it. So what you can see above that jump is essentially some 6 or 7 lines down is after login duration 672 milliseconds. That is essentially where we are giving back control to the Nodes client to start. Yes, we're then not doing other stuff in parallel to the Nodes client start, but But anything after password entry to this particular line, we're kind of blocking the client from starting further. In your case, it took 670 milliseconds to open your desktop, your bookmarks, your names, download new actions from the configuration database, export your names, bookmarks, etc., all into XML files, etc., etc., prepare all of that for the Analyze database. So that should already be an indicator that if the machine is kind of bored, then we're not going to impose any performance problem, because we've done a lot. There's quite a few log lines from where we are at the moment here to the very beginning of after login, where you can see what MarvelClient is doing in detail. Okay, I'm not suggesting that you read through all of that. All I'm saying is you can very easily determine performance problems. We're done here blocking the client. We're giving control over to IBM, or we're then saying is we're registering kind of a listener to understand once the client has started up, when the client or the user is accessing a server for the first time, to then upload the data into the Analyze database. That makes sure that, one, uploading into the Analyze database doesn't block the client start. Two, it makes sure that if you have a laptop user that's not connected during client startup, but connects something like 10 or 20 or 30 minutes later through dial-up, for example, that we then wait for the first server access, however long that may take, and only upload data once a connection to a server has been established. We're then waiting for a minute, as you can see here, so that explains the bump. So essentially we're waiting for 1 minute, meaning that the Node client has started up the UI, kind of giving the end user a minute to start replicating or open the mail file or stuff like that. And a minute after first server access, we then start uploading data. We're listening not just to the end user opening a server or whatever, but we're listening to multiple tasks, because it could be the background replicator accessing the server instead of the user and stuff. And what you can see here is that the first server access was not done by the user himself, but it was done by the end task loader task, meaning the replicator task. That's been detected, and that means that the Analyze action then runs, populating the data into the Analyze database. Now, essentially the log file kind of stops pretty much in the middle, because this log file now stops where we're starting to actually upload the data into the Analyze database. So essentially a log would be a little bit longer on the local machine, meaning it would show how long it takes for each attachment to upload into the Analyze database and then kind of finish. But that's the only difference between the local log and the one that's been uploaded. So given the current configuration, you have full logging of anything from close to clicking on the Node shortcut up to the UI having fired up. Again, please don't ever start looking at all your end users' log files. This is meant as a starting point that if you identify a set of users, a particular location or set of mail server users or buildings, cities or whatever, where you're saying they all seem to have performance problems, it's typically enough to look at 2 or 3 such users, and you would then surely be able to identify whether that's a performance problem related to Node clients talking to the Domino server, or to network drives, or opening up the names as an address book, and then from the other data being able to determine that the names and address book, for example, is in an older ODS format or stuff like that. So don't ever look at this like I have to then look at 56,000 users or whatever, but all you have to do essentially is just look at 2 or 3 of them, and typically it's very easy to derive a performance problem pattern from what MarvelClient is doing client startup. What typically adds to this is, and you might either want to do that from a view level, we typically do that from the XML file level. If we detect that, for example, the log file states opening names or bookmarks or whatever took extremely long, then what we do is we open databases XML. So if you click on the updated link next to databases XML, then essentially that's a list of the databases of that particular user.